Okay, ladies and gentlemen, today we're going to do some more review, and this will be hopefully the last time that we do some major review. We've done a lot with fractions, orders of operations, and now finally we're going to hit integers. Okay, so last day of serious review. So these are the rules that I typically teach students when thinking about operations with integers. If they work for you and you like them, awesome. If you don't like them and you know a different rule or a different method that works for you and it gives you the same answer, there's no problem with that. All right, so if you want, remember, notes are optional. They are your resource for learning material. You need to always write something, but how much or how detailed is up to you. All right, so in thinking about operations with integers, the first thing that we're going to talk about is addition. And I always recommend that you ask yourself the question, do the numbers have the same sign? If the answer is yes, that they are the same, you will find the sum. If the answer is no, that they are different, you will find the difference. Let me show an example of this. So if I have -2 plus 3, those signs of 2 and 3 are different. So we will find the difference. The difference of 2 and 3 is 1. Then all you have to do is keep the sign of the larger absolute value. So which number is actually bigger? 3 is bigger, it's positive, so my answer is positive. Let's look at another example. If I do -2 plus -3, those have the same sign, so I find the sum. The sum of 2 and 3 is 5. And again, keeping the sign of the larger absolute value. The larger absolute value is negative, so my answer is negative. Okay, so we'll do some more examples of those. Let's talk about subtraction really quick. Subtraction is the same as addition as long as you change it to an addition problem. So we do this process of keep, change, change. So how does keep, change, change work? What you're going to do is if you have a subtraction problem, say for example -3 minus 7, we're going to keep the sign of the first number. We're going to change from subtraction to addition, and we are going to change the sign of the second number. So because it was positive, I make it negative. If it was negative, I would make it positive. So now that we've done keep, change, change, we have an addition problem. So we can just follow the rules for addition. Are they the same sign? Yes, they're the same, so we will find the sum. The sum is 10. Keep the sign of the larger absolute value. Okay, let's do some more practice with these. Pause the video and try these on your own. Oh, this one was written very poorly. There we go. Pause the video and give it a try. Same sign or different? Different. So find the difference. The difference of 21 and 12 is 9. 21 is the bigger absolute value, so I keep it negative. 22 and -9, different signs, so I find the difference. 22 minus 9 is 13. The bigger absolute value is positive, so my answer is positive. Same sign or different? Different. I find the difference. Keep the sign of the larger absolute value. Fractions. Okay, in a fraction problem, you are still going to follow all the rules for adding fractions. So I need to find a common denominator, multiply by 3, common denominator, multiply by 5, keep the denominator, and then I'm only looking at these two bits here. I'm adding, they're the different signs, so I'm going to find the difference and keep the sign of the larger absolute value. Check to make sure it's simplified, and I have my final answer. Okay, so in general, I've had some people have questions about negative, negative. A negative and a negative combine and it becomes a plus sign. So anytime you see a negative, negative, it is a positive. The other thing you want to keep in mind is A and its opposite, negative A, will give 0. Okay? Here's some subtraction problems. Remember, keep, change, change. So pause the video and give them a try. Okay, so keep, change, change. I have different signs, so I find the difference. And the bigger number is 10, so it stays negative. Keep, change, change. Same sign, find the sum. 14 plus 19 is 33. Keep the sign of the larger absolute value. 19 is bigger, so it stays negative. Keep, change, change. Different signs, find the difference. Keep the sign of the larger absolute value. 12 is the larger absolute value. Hope you guys are doing pretty well with this. Alright, so when it gets more complicated is when we have multiple steps and we need to follow the order of operations. So again, I have a subtraction problem here, but let's see if I can just take it step by step. I don't have to keep, change, change, but I can. 12 minus 5 gives me 7. Continue that minus 7, and 7 minus 7 is 0. Or I could have done it with keep, change, change. 12 plus negative 5, different signs, find the difference. Keep the sign of the 12. Minus 7, keep, change, change. Opposites give 0. Okay, so same answer either way. Why don't you push pause and try the second one? 9 minus 6 is 3. Remember, a negative negative is a positive, so we can rewrite that as 3 plus 3 plus 8. 3 plus 3 is 6, plus 8 is 14. Alright, so let's move on to multiplication. The thing I always like to say in multiplication and division is negatives in pairs are positive. So if there's a pair, a partner, it becomes positive. A partner of negatives will become positive. If they are not in pairs, they're negative. So here's a partner. They're both positive, so answer is positive. Here's a partner, 2 negatives, so the answer is positive. These are not in pairs. One's negative, one's positive, so the answer is negative. One's negative, one's positive, answer is negative. Okay, so let's give this a try. Negative 3 times 8 is going to be negative, because it's not in pairs. 3 times 8 is 24. Negative 5 times negative 2, negatives in pairs, so my answer is positive, and 5 times 2 is 10. 0 times negative 50, not in pairs, so my answer is negative, and 0. But is there a negative 0?
Hey, Lizzie, could you find this?
Sorry about that interruption, guys. I forgot my walkie-talkie was still on. So no negatives with zeros, but we do write 0. Okay? And the letter D here, we've got negatives not in pairs, so our answer is negative 50. 10 times 5 is 50. Alright, so looking at some more complicated problems, decimals, fractions, we've got negatives not in pairs, so our answer is negative. 5/6 times 1/4 is 5. 1 times 5. 6 times 4, 24. Okay? With our decimal here, if you remember how to multiply with decimals, you can do that. 2.3 times 6. 6 times 3 is 18. 6 times 2 is 12. 13, we only have one decimal, so 13.8. And remember, we have only one negative. Negatives are not in pairs, so our answer is negative. All right, so now here's where those negatives in pairs really come in handy when you have more than two numbers. Here we have negatives not in pairs, so my answer is going to be negative. 5 times 0 is 0. Times 3 is 0. So again, there's no negative 0, just 0. Here I've got a pair, but one left alone, so my answer is negative, because my negatives are not in pairs. 1 times 6 is 6, times 7 is 42. Alright, so exponents. This is a really important difference and probably the only new thing to you on this entire video. The parentheses are super important. Notice the difference between these two problems. The top one has parentheses, so it's the whole number negative 2 to the 4th power. So I'm writing negative 2 4 times. Okay? On the bottom, there's no parentheses. So that negative is all by itself, and the 8 is being raised to the 2nd power. So I've got a negative all by itself. I've got the 8 being written 2 times. Do you see the difference? This, in the second one here, the negative does not stay with the number because there are no parentheses. So in the top one here, I have negatives in pairs, so my answer is positive. 2 times 2 is 4, times 2 is 8, times 2 is 16. On the bottom, I have negatives not in pairs, so my answer is negative, and 8 times 8 is 64. All right, division, same rule. Negatives in pairs are positive. 42 divided by negative 7. They are not in pairs, so my answer is negative. 42 divided by 7 is 6. Negatives in pairs, so my answer is positive. 16 divided by 2 is 8. Negatives not in pairs, so my answer is negative. 80 divided by 10 is 8. All right, last thing I want to make sure that you either have heard before or haven't, and we'll learn right now, is division involving 0. If you have A divided by 0, the answer is undefined. We can't divide by 0. It's not possible. If I said take this group of 20 students and divide them into 0 groups, that's impossible. You could have one group of 20 students, but you could not have 0 groups. So the only thing that is possible with division and 0 is 0 divided by A, the opposite. You can take 0 people and say divide them into 3 groups. That will give us 0. So 0 divided by negative 7 is 0. 8 divided by 0 is undefined. Okay? Your homework tonight is on My Math Lab. It's called Chapter 1-567. Have a great day.